pleased to be able to introduce her. Terry's currently a senior fellow at the Woods Institute for Environment at Stanford and has several other appointments there. She holds a BS from the University of New Mexico, an MA from Colorado, and a PhD from Princeton. Her dissertation was an absolutely pioneering look at biogeography on a continental scale, and it really presages her current work. I'm not going to go into a lot of details because I want the time for her to talk. But she's built on this foundation in large-scale biogeography to shape, really, the study of climate change and how it will affect the distribution of species on regional and continental scales. I mean, I think all work in this area has really been heavily influenced by Terry's pioneering contributions. It's really largely through her work that we know climate change is already having a substantial impact on ecosystems around the globe. Among her diverse services and awards to the world, she has twice served as a chapter lead author for the Intergovernmental Panel on Climate Change, and I've been spared that honor, but I can assure you it is one of the most demanding jobs that one can undertake in science, given the level of consensus that one has to hammer out amongst diverse scientists from around the globe, and then the fierceness of the review process, which is as well orders of magnitude beyond anything we experience when we do our normal peer review papers. And as you know, the IPCC was awarded a Nobel Prize in 2007, so Terry is a co-holder of a Nobel Prize. This is Terry's second visit to MSU to share with us her research on how climate change is changing Michigan, and we certainly welcome her back. Today she will share her insights on climate change in Michigan, our species adapting or going extinct. And with that, and our format is we'll have some time for questions and answers. Do that. Terry?
Well, thank you for the introduction. That's very, very kind. The IPCC is really a tough one to work on, actually, and it's all pro bono, and you sit there in the middle of the night saying, why in the hell am I doing this? And then to you say that more than once. So, anyway, I'm told I have to talk through the mic, and that's going to be hard for me because I love to pace, so if I leave the mic, holler at me, look back. Okay, what I want to do is basically talk to you about how species are affected by climate change and what's basically coming. So what I want to do is talk about our rapidly warming world, then how do species adapt, and then what happens when species can't adapt? What do we do? Okay, with all the naysayers around so much right now, I'm gun shy of not saying anything at all about climate change. So this is my climate change part. So yes, Virginia, the climate is warming, and it's warming more rapidly as we go forward. So 150 years, it was 0.05 C per decade, 100, 0.07, 50 years was 0.13, 25 years is 0.18. Now, this is the plot that really scares me the most, because it has to turn over, and it has to turn over soon, and I don't see that we're doing much to get it to turn over, or get cooler, basically. Okay, so this is Greenland, and actually these are pictures taken with my iPhone out the window. I was banning to him, and I was going to stay awake long enough to get these pictures. So anyway, but you can see there's a lot of streaming ice that's going into the seas. My husband and I did go to Greenland, and it felt like being at ground zero, because we truly were at ground zero. It's melting, and I could see that from the plane. And can you see those little blue dot things? Yes? Okay. Those are basically melt lakes, and there are rivers, kind of rivers, in between some of those, and then all of a sudden the river will disappear and go down. And what we don't know right now is what that is going to do. There's one whole camp of people who say, well, if we have so much water going down, it's going to hit down to the bottom, and it's going to then allow the ice to move more rapidly. There's a lot of dynamics in there, but anyway, to move more rapidly. Other people are saying, no, it's just going to get frozen before it gets down there. I hope the latter is true, and I'm concerned that the former is the one that is right, because Greenland is melting a lot faster than any of the models are telling us. And because it's melting so much faster than any of the models, that then means that it was not talked about in the fourth assessment report of the IPCC. So they assumed that it wasn't melting at all. So I think that's the wrong way around, but they felt as though they couldn't say anything because they didn't know anything. Well, I guarantee you, I can tell you it's more than zero. I don't know how much more, but so that's one of the things you have to worry about is what we do know, what we don't know, and what is included in what we're telling you. Actually, when we were in Greenland, we were talking to a bunch of scientists who were trying to figure out what's going on with these mullions, these things that go down, these waterfall type things. And what they had done was they had gotten permission to drop things into the water and see if they come out into the ocean or not. I said, oh, what are you dropping? This for sure is true. Little yellow duckies. That's a quote. And they are. There are these ducks that are about this big. And they're ducks that are these little, he says, well, you know, they're 50 cents. I could go out and get them anyway. And then we talked to him later, about 2 years later, and he was all excited because now he has smart little yellow duckies. Now they have transmitters on them. But anyway, so the high tech of our field. Anyway, I thought that was great. But it's melting, folks, it's melting. And here's Greenland. This thing really scares me also. The little squares that you can see here and there on 2005, some on 2002, those are locations that have never thawed before in millennium and millennium. So things are going much more differently than they've gone in the recent quote-unquote recent past. And if we melt all the ice in Greenland, we really, well, in Michigan, you're fine. In California, I'm not. So the sea level is going to go up quite a bit. Okay, so now what's happening when this happens? Well, we have years that have late snow melt, and that's the norm. But now we're getting earlier and earlier and earlier and earlier snow melt. And what Westerling did is he looked at all of the fires that occurred in the Southwest. And the years that there was late snow melt, there were fewer, smaller, and colder fires. The years when it was early snow melt looked like that. Isn't that striking? So we're having more, larger, hotter fires. Now, which one are we going to have more of? More, larger, hotter fires. So California, you thought it was burning up recently, it's going to burn up a lot more. So this is something that we need to be looking forward to and making sure that we're doing something to try and stem it. Okay, now this also is a knee-jerk reaction of mine because I am so sick of naysayers that I want to show you something that the naysayers have done. They did a film called The Great Global Warming Swindle, and they lie. And you can put that in print. They lie. And I'll show you how. Okay, this is one of the plots that they had. Temperature is in blue for some reason, and sunspots are in, that's what they call solar, are in red. This is the first version that went out. And the people who did the study said, that's wrong. You did that wrong. So they fixed it. That's what it looks like. Now, do you see the difference between the two? Okay, I have to move for this one. If you had to interpolate between this point and that point, I will bet you $1 million, not one person in here would say it goes right like that. Right? That's what they did. Now, if you can tell me that's not lying. So anyway, I have a lot of knee-jerk reactions to naysayers right now. We're getting death threats. It's really getting quite ugly. And what can we do about it? We're scientists. We don't know what to do about it. Okay, so what's happening as far as global warming? In 2001, if you have A1T, A1T is a scenario that is, T stands for technology. There's a very good flow of technology going between countries, among countries, and the people are being very careful about warming yada, yada, yada. Well, so they plot this out and looked at degrees C. And the green one on the bottom is the 10th percentile of climate sensitivity. So that means that we have a 90% chance of having that happen. The yellow is the 50% percentile, and that means we have a 50% chance of it getting there, given this scenario. And then the red one is a 90%, I can't say that, percentile. So we have a 10% chance of getting to that temperature. And I don't think anybody would say that if the global average temperature went up to 8 degrees C above that which was in industrial times, I think we would all say it was a bad thing to have happen. So this is the technological one. This is the nicest one that we can really kind of hope for, A1T. This is A1FI. FI stands for fossil intensive. So, oh, it's time to wake up. Okay, are you all awake? So this is for fossil intensive, and you can see now we're going up to 13 degrees. All right, if there's a 10% chance in 2100 we could be to 13 degrees. I hope that's not true, but I actually think it is. So then what I wanted to do is look and see what happened with the animals, and what I did was I did a transect with a high school student who happened to live in Minneapolis. So that was the transect he chose to do. But it's close to Michigan. And what we did was, I was involved, so it had to be with birds. So what we did was we looked at where the winter range limit occurred for all the birds or all the songbirds that crossed that transect line. And what we found, and it's really kind of complicated, but the bottom dashes here are where the species are right now. Down here are species. So if you're an ornithologist and you want to really entertain yourself and not listen to me, you can sit there and try to figure out what these different codes mean. Anyway, we have different birds down here. This is where their range is now. This is a 90% chance that they will get there, 50% and a 10% chance. Okay, so this is for both technological and fossil intensive for 2050, because there's not really much difference between them. So now let's look at what goes on. That's the fossil intensive. So at the extreme, you have the American goldfinch, ANGO, has a 10% chance of moving its range from here all the way up to there. Is it going to do that? No, because the habitat's not there. The point, what we were doing was saying, where is the temperature going to be similar to what it was before? So, okay, so that's fossil intensive. Let's hope technological is better. It's better, but it's not much. So you still are going to have, you could have a huge shift going on. And the 90% shift we can pretty much bank on right now. Okay, so now, how species adapt. Okay, there are different types of changes. There's range shifts, phenological shifts, other kind of changes, which reminds me to talk about genetics and things like that. And then you have extinction. So I want to talk about all of those. First of all, the type of changes are range shifts. This means that species are going poleward because as it's getting hotter, the cooler areas are up north, so they're shifting up. They're going up in elevation on mountains. And in the ocean, they're going deeper because the deepness is where it's cooler. And we see this all over the place, except for these guys. The bad news is that the ice cap is melting and it's going to be almost impossible to catch seals. The good news is, if we keep moving south, there's a ton of fat animals called humans who can't run very fast. So the polar bears are going the wrong way, but actually, do you see down in the corner it says map of meat? Yeah. Well, things are happening to polar bears. There's a lot of absolutely horrible stories about it all. But the thing is that we probably will never lose the polar bear. Because I think 95% of the zoos I've ever been to have at least two, right? What's going to be lost is their behavior in the area. And that's where this comes in. So the polar bear now will kill seals. It slings all the blood and guts literally all over the place. The Ross gull, the ivory gull, and the Arctic fox come in and clean it up. The Arctic fox is smart enough to go and feed on other things. both the Ross gull and the ivory gull are declining in numbers already. And it hasn't been that long that this has been happening, and they really are dropping. It's noticeable. Okay, so what do we do about all of this? We have to think about what's going on with different biomes, and the forest biomes are really quite important. And when I saw this slide, I was really struck by it. I didn't realize that the boreal forest had so much more carbon in it than the other two. So the boreal is huge. And actually what it is there's about 208, I don't know how they get it that precise, billion tons of carbon locked up in Canada's boreal forest. And it's worth, and it's no longer greater than, it's about equal to 20 years worth of the world's fossil fuel emissions. If we lose the boreal forest, think of the pulse that's going to go into the atmosphere. So we have to worry about large mammals. Species are moving north. I keep saying we've got to keep the boreal forest intact because there has to be some place for these species to hang out in. And it's basically their last habitat before they fall off into the ocean. And this is where they need to be. So we've got to do something to preserve the boreal forests. But there's a lot of threats. And the one that I just put up is the worst. That is the tar sands. And as oil gets more and more profitable, the tar sands get closer and closer to being used. And if that happens, the amount of CO2 that goes up is again going to be astronomical. So we truly need to stop the tar sands and then the dams. Okay, so now if species now are shifting, pretend that we have two species, species A and B. And species B wants to go up to this area where it's cooler. So the species is going to be shifting, the individuals are going to be shifting along and moves away. There's two things that are going on here now. First is that the community within which they were, the A and B were together, now has split. That's fine if they don't have any biotic interactions. But there are not very many species that don't have biotic interactions that are actually in a community. So if you pull apart predator-prey relationships, competition relationships, mutualistic relationships, you're going to have trouble. What kind of trouble? I don't know, and I think that's actually the frontier for study in the next 5 to 10 years. But the other thing that's going on here is, where is B going to? Now, if B needs to get up to that blue square, rectangle, and it only gets partway there because it can't get any farther up because something's in its way, what's going to happen to B? I don't know. It's possible that most of B will go extinct, but there'll be a little area that's in the blue area that will be able to survive, but it's going to be low in numbers. This is just a just so story. What I'm trying to do is say, when we have this tearing apart of our communities, we really don't know where it's going. We just don't know where it's going. And this is some stuff that Barb is back in the back did with Phil Myers. This is looking at the southern flying squirrel and the northern flying squirrel. And the southern flying squirrel, which is on the bottom, whatever that is actually moving north. The northern flying squirrel isn't moving south. That's not what that arrow means. What it means is it's declining in population. So what's happening is that these species really are trucking along. They're moving all over the place. Some of them are going to win, and some of them are going to lose. Some of them may not be affected at all, but I don't believe that. I think everybody's going to have to be a winner or a loser. And the number of species that are going to be losing is pretty substantial, I'm afraid. Okay, another type of change is phenological shift. This is back from a zillion years ago, and just showing, this is a meta-analysis that I did a long, long time ago. And what it's showing on the x-axis is the number of days changed per decade, and on the y-axis is just frequency of species. And you can see that most of them are negative, and that means that they're coming earlier in the spring. Phenology means change of time, I should have told you that. They're coming earlier in the spring. The ones on the plus side are coming later. You can see that there's a very large preponderance of coming earlier. There's a big X at 0. because I didn't look at any of the species that weren't changing at all. These are only the ones that are changing. Of the ones that are changing, they're changing by about 5 days per decade. This was done about 15 years ago now. And it was true then for the previous 30 years. It is still pretty much true. It's not going much faster than it was then. So it's about 5 days per decade change in these species. Now, let's talk a little bit about winners and losers. This is a bird, a common cuckoo, that occurs in Europe, and it lays eggs in other birds' nests and let the other bird bring up the baby. And the thing that has happened is that the common cuckoo is not migrating back in any earlier. It's still migrating about the same time. So probably it's being triggered by day length. But one of the species that it parasitizes, one type of species that it parasitizes, they are coming back earlier. That's the short distance migrants. And they're arriving much earlier than the cuckoo. They are able to get their nest built, able to court, nest built, eggs laid, and babies before the cuckoo gets there. And so now they're going to be a winner because they're not going to have to do what this poor parent is having to do, is feed this baby that's ginormous. Oh man, only a mother could love it. So they're going to win that way. The cuckoo's going to, well, will the cuckoo lose? Maybe the cuckoo will then turn and lay more eggs in the long-distance migrants. So then the long-distance migrants are going to be the real losers. So there are pluses and minuses, and we have to remember there are pluses and minuses. But the main thing that there is change. That's what's really going on. Okay, so now let's go on about what about when species can't adapt? And this is the stuff that really is pretty controversial, and there's a lot of folks out there trying to wrestle with this because it's imminent. I truly believe that we're standing on the edge of a mass extinction event. I truly believe that. Mass extinction event, I think we're going to lose at least 40% of the species on the planet. Could be as early as 2100, maybe a little later than that, I don't know. If it gets worse, it could be a larger percentage. The thing is that it's a possibility that we could lose an awful lot and probably most of the species in the oceans. And that now is going to cause a lot of turmoil to humans because about 37% of the human population lives along the shoreline, and about 90-something% of them make their living or feed themselves from the ocean. If those species aren't there, how are they going to eat? They're going to be moving in here. People ask me when I give talks like that, well, where should we buy a house for our kids so that they'll be able to, I say, Michigan. They're a long way away from the ocean and have a lot of water, at least right now. Okay, so there's this hierarchy of actions that need to be taken and need to be taken by us when species just can't adapt. So we first have to be monitoring for change. Now, that is first and foremost, and that is the hardest of these actions to get money for. It is really difficult to get money to continue monitoring for year after year after year after year. People want to be able to say, oh, I gave money and they found out this. Well, they may not find out this for about 15, 20 years. We have to do this. We don't really have a choice. We need to know what's going on with the species. The other thing is we need to continue managing species. And that is really quite important because we're going to have to do more of it. And the more we do, the better we'll learn, and the more I think we can save. We can do managed relocation, and that's the new word for, I always forget the old phrase, assisted migration. Assisted migration. Managed relocation, we'll talk about that in a minute. And then there are species that are completely out of our direct control. And we have to accept the fact that that's how they are. Okay, continue monitoring and managing. One of the best species that has been monitored and managed is right here. It's the Kirtland's warbler. And there are the different populations. They purposely have separated populations to some extent in order to make sure that something doesn't go through and kill the whole population, which is what could happen with whooping cranes. You can I'm a bird person, so I talk about birds all the time. But the whooping cranes go to all of them go to one place in the wintertime, and if we had an oil spill, they'd be toast. Well, so what they're doing with the Kirtland's warbler is they are separated apart and monitoring and managing. They got a congressional approval to catch cowbirds, so that the cowbirds were not laying eggs in their nest, which they were. And I think that was the main, is that the main cause?
Lack of habitat.
Lack of habitat too, because they have very special habitat needs as far as the tree type and the soil type. Okay, the other thing is that we've got to be very clever about what we're going to be doing, because we can't do business as usual anymore. And so we have to start encouraging people to think outside the box. And I hate that phrase, but you know what I'm saying. So here are northern marine mammals. There's ice obligates, the walrus, the seal, and I don't remember what the name of the seal is. They are ice obligates. Again, my favorite word, they're toast. The ice is gone or going, and the walrus now are hauling out on land, and when something, and they're huge herds, I mean ginormous herds, and if something scares them, they just take off and try to get back in the water. Well, all the babies and the slow individuals get smushed, literally get smushed. So it's a hard situation. What do you do with the walrus? I'm not sure we could put it in a zoo. What do you do with it? What do you do? I think it's a ring seal, even though the other one looks like a ring seal. Anyway, ice obligates we have to worry about. Have to worry about those that are associated with ice, so the narwhal on the bottom that looks like the unicorn, and the other seal that's up above it they like to have ice, they need ice. Well, they like to have ice because it provides them a safer place for feeding and for other things, but for the narwhals, that's primarily what it is. And then we have the ones that are seasonal migrants that come up into the area where there's ice. And they don't absolutely have to have ice, they just have to have a cool area to actually survive. All right, what's going on with these animals? Well, we need to start monitoring them. We need to somehow figure out what's going on. Well, when I was in Greenland, I met with a lot of Inuits. And all of a sudden, one night, it was one of these epiphanies, you know, oh my God. Inuits, okay, first, we can't go out and bother any of these species because they're endangered. Inuits, on the other hand, are given permits to do X, Y, and Z for these species for subsistence hunting. Well, duh, let's have them take the information that we need for monitoring. So get the subsistence hunters to actually do that monitoring. Now, I say this several times. I've said it to NSF and they've just laughed at me. Okay, laugh at me, but I still think we can get information. It may not be as wonderful information as if one of you went and did it, but it's better than no information at all. So anyway, that's one thing. Okay, managed relocation. This is a really tough one. And this one, if I don't have naysayers in the audience, I have people react to me on managed relocation. So managed relocation is a tough one. Why are you having to do this? Well, first of all, if you're going to do managed relocation, you have a lot of obstacles. Money, political power, willpower, people power, space, infrastructure, invasive species. The one I don't have on there, which is the most important, knowledge. We don't know how to pick up a species and move it and make sure that it survives unless we put it in a zoo, and not all of those survive. The places that I'm worried about are habitat islands. This is an example, Sky Island in southeastern Arizona. And what's happening is that here's this high area. You know, the people in here who are old, like I am, remember John Wayne movies? And they'd have these big, huge rocks that come out right out of the desert floor, and they're flat on top. Well, flat on top, they had actual species. They speciated up there. Well, they can't go down, walk across, and come back up someplace else. It doesn't work. They can't do it. So we're losing them. This is another habitat island. And this is again, what are we going to do with all the species that are there? I don't know. So we need to worry about this. We need to worry about how far away a cool refuge is. Because if a cool refuge is somewhere close, then maybe the species can move. So if it was on top of this sky island, if there happened to be another sky island right here, and they just went down a little bit and then came back up and were there, they could do that. Okay, so how far away are these refuges? And what this is looking at is different links. And pretty much it's telling you where mountains are, because mountains allow you to have a very close place where you can go up and get and be okay. But then you have to worry about what's happening to the species that are up on the top of the mountains. Where are they going to go? They're going to pop off and go extinct. There's no place for them to go either. Okay, so there are areas now where there's a long way away, there's a short way away. We've got to be worrying about those species that don't have cool refuges very close that they can get to. That, to me, is a pretty good definition of what we need to be thinking about right now. Now, we do have managed relocations that have worked. This is a California condor in the Grand Canyon National Park. We tried to release them in California, and some of them worked not very well, so they decided to try it into Grand Canyon, and it's worked pretty well. So we can do managed relocation. This is a result of managed relocation. But if there's no access to the type of cool habitat that they need, what that means is then they're called functionally extinct. And what functionally extinct means is that unless humans go in and pick them up and all the things that they need around them to survive, move them and put them down and get them to grow in this new place, but not be an invasive species, because it will hurt all the species there, that's a functionally extinct species. Those are the ones that I think we need to be worrying about as far as managed relocation. So can we go and pick species up, shift them over, and move them down? Well, the bottom line is if we don't, extinction is pretty much what's left. And that's a very sobering thought. And if we're going to have, according to the IPCC, they said that there could be, if we go up to 2 degrees Celsius above industrial, which we're going to do, I guarantee you, well, I can't guarantee you, but I guarantee you, we could lose as many as 400,000 species. 400,000. We need to be able to manage relocate them, but we don't have enough to do that with. We just don't have the resources. So then the question comes is, so how many species do I need? You would be shocked at how many times I'm asked this question. We don't need all those species. Let's just get rid of them all. We just need cows and grass and, it'd be interesting sometime to actually do that and figure out how many species we actually use in a lifetime. But anyway. Now, let's go on and talk about those that are out of our direct control. And this is you guys' state fossil. And it went extinct. Now, what's going to happen to all those species that are actually beyond our control? A lot of those are the functionally extinct species that we can't do anything about. And they really don't have a choice. They really, truly, I believe, are going to go extinct. If you could think of something else, I would love to know. And then this is the thing that's the topper to me. I'm not a marine biologist by any stretch of imagination, so I haven't been following this very well, but then when I get snippets of it, I about throw up. This is the ocean acidification, and it's just showing you up to 2000, a little bit farther than 2000 where that line is. That's all real data. Those are all real data. The blue lines are showing you basically the variance, the red lines showing you basically the mean, and then the projection is to go down and down and down. Okay, big deal. Why are we worried about that? Well, as you get more carbon into the ocean, it makes carbonic acid. Carbonic acid then pulls away from organisms the carbon that they need to build shells and bones. Anything that has a shell or a bone could be in quite a lot of trouble. And anything that relies on anything that has a shell and a bone could be in quite a bit of trouble. This is an example of a snail that was dropped, and I don't know I don't remember what the acidity was in this one, but I think it was actually where the black line is. I think that's why I put the black line there. Anyway, you can see that it's eroding away. And as we go forward, as we put more CO2 into the atmosphere, more carbon is going to go into the oceans. Well, that's good because it'll help cool our planet. Yeah, it will, at the expense of the animals in the oceans. And this is something that's brand new. Just David Keith was the head researcher on it in Science. It's 4 days old, and I'm really upset about it. What they're talking about, the red the red spikes are when the sun is cool, and the blue spikes are when the sun is hot. Now, why didn't they change those around? I don't know, but anyway. They wanted to make it difficult, I guess. Anyway, how does sun get cool? Has sunspots. Sunspots really blocks quite a bit. So now what they're doing at the very end over there, what they're doing is they're saying, okay, let's shoot salt into the atmosphere, little mirrors into the atmosphere, dust into the atmosphere, you name it, shoot it into the atmosphere. Shoot it up high enough so that it works like Pinatubo. Do you guys remember, the old guys in here, remember Pinatubo when all of a sudden the sunrises and sunsets were purple? You know, that was because there was all this gook up in the high atmosphere. That's what they want to do. Okay, for how long? Who's going to shoot it? Who's going to decide when to shoot it? And what in the hell are they going to shoot it with? I don't know. But people are talking about this a lot. It's called geoengineering. And what it's doing is it will cool down the Earth. Yes, this will cool down the Earth. I guarantee you, it will cool down the Earth. And what happens, though, is if David Keith and all, David's a great guy. I really like him. He's been led astray. If this happens, what's happening to CO2? It's still going to go up and up and up. As it goes up and up and up, the pH of the ocean goes down and down and down. That's what I'm worried about. So we have to be an all systems thinker here. We can't just say, well, I want to cool off the sun. Well, okay, cool off the sun, but you're going to ruin the world. So, in my opinion. So I'm always asked, is this what I should do? Just sit around and wait for speciation? A lot of people believe that's true. So let's talk about extinctions here. On the bottom is MMBAL. MM is mammals, B is birds, A is amphibians, all is all. And then we have a logarithmic scale of the number, basically, of extinctions per 1,000 species per millennium. So the baseline, which is fossil, is below one individual going extinct per 1,000 species per millennium. Now, the extinction rate has gone up by 4 levels of magnitude. It now is up to around 100 for mammals and a little bit less for birds. And amphibians, I don't know what's going on there. But the mammals and the birds are well studied. So we're up to 1 out of 10 species is going to be going extinct every millennium. The thing that scares me about this is an article that I just read by Bob May, who is talking about what the rate of extinction was when we had the mass extinctions. And he says this is right on course. I'm not sure he knows how that's true, and I'm not sure about all of that. So I don't put it and say this is what's happening. But it's possible. And so then you can see there could be future extinctions. And we're going to have extinctions. So what do? We're not certain why they disappeared, but archaeologists speculate that it had something to do with their size. So maybe, and I do believe this, I do believe that we can turn this around. If I didn't, I'd go play at Disneyland. There is hope. There are species we can save. There are species we can't, and we have to accept that. And that's basically, we have to set priorities. And we've got to say, these ones we're going to work on, and these ones we have to let go, because we don't have the resources. And that's a horrible thought. It's a horrible thought. But if we don't do that, more of the species that we could save will go extinct. Okay, this is another way we can do it. On the bottom is the world, California, US, and Texas, and on the y-axis is the tons of CO2 emissions. The world is very low. California, done so well. The United States is about twice that, and guess what? Texas is high. Look at the difference between California and Texas. What is different between California and Texas? California, we live by laws. We live by regulations. We enjoy the fact that we have regulations. That may sound crazy, but we really do. Texas, they're hell-bent for high water. And they're going to try and make sure that that's what we stay. And if we stay up there, I'm really quite concerned. But there is hope. The old people in here, but the words of the prophets are written on the subway walls. Did you guys remember that? Simon and Garfunkel? Okay. That's a picture that a colleague of mine took in the DC subway. And he was late for a meeting. And he says, oh, screw it. I've got to run back and get my camera because they might take it down before he gets his camera. So he was late to his meeting. He was chairing the meeting too. Ran back, got his camera and took this. And so there is hope. There is hope. People do understand what they're doing. Some people don't want to, and some people are lying. I truly believe there's a lot of people who are lying. But there's enough of us who would do this if we had the opportunity. So what do we do? What do we want? I don't know what we really need, but what I think we need is we need to have a change in how we do things. I was talking to a woman today about green roofs. We could change cities into some place where species could occur, insects and birds at least. I said it the last talk that I gave when somebody asked me, okay, so what do we do? What do we need? And I said, I don't mean this to sound flippant, because it's completely honest, but it is going to sound flippant. We need another Bob Dylan. We need somebody to help us, lead us into this change. We did it before. We did it with Vietnam. I'm old enough to remember, doing demonstrations for the Vietnam War. Well, we changed. We changed the way that the world saw the world. We can do it again. I really do believe so. Thanks for listening.
Thank you, Tony. That was great.
We have some time.
Yeah, we have 15 minutes or so for questions, so I'll let you field them if that's all right.
Okay, guys, I didn't say anything controversial whatsoever, huh? Yes, sir.
Well, just an information point. I've seen that graph that you put up for earlier with the sun activity.
Oh, you have?
That was filled in. The question is where it's the missing data. Is that missing data or
Missing data.
wasn't there solar activity?
No, there's missing data.
Missing data.
There's missing data. And it's the people who actually did the study and actually drew the plot, brought out their study and said, here, look at it. There is no data. There are no data in that area. Yeah. They're lying. Yeah.
Yeah, one of the things when you ask what can we do, a lot of what I hear is focused as you did the per capita amount of carbon and actions. At some level, are we avoiding the issue of just sheer number of people and population growth as well?
Ooh. Yeah. Yeah. What should I really be talking about is population. And why do I not put it in my talks? Because everybody then focuses on population because it's such a knee-jerk reaction to people. So it's strategic. I have actually stopped putting population in my talks so that people don't look at that and forget about everything else. But you're exactly right. You're exactly right. People are the problem. There's the people. Well, actually, that's not completely true. It's not just people. It's people and affluence. So if we had the number of people that we have right now and we didn't have our affluence, it would be a lot better. But now people are trying to get to higher affluence. So, you have to worry about both of those things, population and affluence. Yeah, good question. Yeah.
you talked a lot about animals. The habitat has to go with them. Is there research out there that
Oh, yeah.
that gives us some ideas about?
Oh, yeah. I'm just an animal snob, sorry. I mean, literally I am. I was just writing a grant proposal last night, and I got comments back from people, and they said, where are the plants? Where are the plants? Where are the plants? Where are the plants? I just don't, I'm sorry. The plants are doing the exact same thing. You know, now, can a tree move? Yeah, tree species are moving actually really rapidly. You know, that type of thing. So you're right. Yeah.
Is there any work showing what the ocean acidification does for the algal blooms, considering they're the principal organism in absorbing carbon dioxide?
I remember talking about that with somebody, but I don't remember what it was. I'm sorry, I can't tell you. But I know it's out there, because I do remember talking, I don't even remember who it was, but anyway, talking to somebody about it. So sorry, I can't help you with algal blooms. That's worse than plants. Yeah.
On some of your earlier slides, you talked about the 10% chance, 50% chance, or 90% chance that we'd get there, and you said that the 90% chance or the 10% chance that we would get there, and then you said, but you thought that that was where we were going. Can you elaborate on that?
Right now, well, okay. The first working group of the Intergovernmental Panel for Climate Change, the IPCC, are responsible for coming up with the different scenarios that they think is going to happen. And there was a lot of politics and junk behind it all. But anyway, the one that they drew that was going to be the worst, we're above it already. So those plots actually came from the third assessment report. And those are higher, those were actually higher than the the fourth assessment report, until some governments made them change, but it came out in print that it was lower. But anyway, the point is that we are higher on that curve. We're going faster than we thought we were going to go. And I don't see anything changing radically soon. So the other thing that I think is going to happen is we're going to go up, we're going to have an overshoot and then come back down, and then level out for a while. But I'll talk about that in the next time. So, did I answer your question? I'm
Yes.
sure I did. Okay. Yes, sir.
So given the limited resources and the thousands of species that we have to preserve or help,
Yep.
So is there a protocol or an approach in choosing which species to preserve?
Yes. On the battlefields in France, they had a lot of wounded, very, very severely, and some not so severely. And they had X amount of doctors, Y amount of space, and Z amount of ability to actually do something for these people. Beforehand, and that's the key, beforehand, they figured out, if I can save this person in an hour and a half, I'll work on them. If it's going to take me longer than that, I have to let them die. Because if I don't, and I work on this person for 8 hours, all these other people over here are going to die. So that's what happens, is you have to come up ahead of time with what you're going to do. Are we going to be able to do that? No, we're not. Because everybody's going to disagree. You know, do we save a nematode, or do we save the polar bear, or do we save, you know, I think what it's going to come down to is actually prioritizing. It's what the managers are going to be able to do is, I've got X amount of money and I know how to save this, I'm going to go save it. And the other ones I'm going to let go. Are we going to make huge mistakes? I guarantee we will. Yeah, I guarantee it. Yeah.
So along those same lines, if you were going to set up a monitoring program, how would you prioritize what species to monitor and not monitor?
Depends on where you're doing it.
Here.
Here in Michigan? Kim, you answer that one. I'm not sure I can do that.
I mean, would it be threatened and endangered species? Would it be common? Would it
I
be
see what
something
you're
that
saying.
has
Sorry.
specific habitat requirements?
Okay. Yeah. What I think you need to do is you need to be monitoring enough so that you know enough about each of those groups, right? So a long time ago, Jared Diamond published what he called his green list. species that we don't have to worry about. We need another green list. We need to know what species we really don't have to worry about, as long as, and then you have to have the list. Then you need to monitor those species that are in between to figure out, okay, which ones can we do something about, which ones do we not have to do something about. And then endangered species, I think you have to do, I don't believe I'm going to say this. You have to do it for ethical reasons, but actually I think you probably should let them go. And please don't quote me on that. But I truly think that's right. Because unless it's an endangered species that is providing something for a very important species, we need to continue monitoring some of them, but I'm not sure. I don't know. That's a real tough one. I mean, I always get hollered at for playing God. I'm not playing God, I'm being realistic. You know, what do you do? Yeah.
Another complicating factor in this is invasive species.
Yep.
I mean, you look at the Great Lakes, I mean, the list is humongous. I mean, we have stuff like Asian carp and all these human-induced reasons that the species are invading. So that, separate from climate change altogether, could just have a huge, extinction wave of native species.
That's right. Absolutely.
Irrelevant of climate change.
Absolutely. The other thing that I didn't touch on here at all was talking about synergistic effects. So you have synergism between invasive species and climate, habitat destruction and climate, all these different things and climate. Species can withstand a lot, but it's just like you and me. When we get really, really, really tired and we've pulled 3 all-nighters all right in a row, and I don't do that, but anyway, 3 all-nighters right in a row, you're exhausted, and then somebody walks up and sneezes on you and you get sick just like that. Well, when you're overly stressed, you don't make it. And that's what people say, what can we do right now? What we can do right now is take as many of the stresses off of the plants and animals as we possibly can. Can we do that all? No. Can we try? Yeah. But invasive species, too, are another group that I think need to be monitored, because they may be the only species that are around in 200 years. Seriously. Yeah.
In trying to sort out all the reasons for extinctions and the actions that we might take to ameliorate them, I'm having a hard time working through. I totally agree that we're on the hinge of an extinction event, but it's so disparate. The reasons we mentioned invasive species, global warming, and then like amphibians are being wiped out by chytrid fungus far faster than global warming ever.
That's right.
The turtles are being eaten to extinction. Primates in Africa are being bushmeated into extinction. And all of this is going far faster than global warming will ever wipe these things out. So how do we apportion our resources to address which problem? I guess
it's a very good question. It's a very, very good question, and people have been really unhappy with me at saying we need to be working on global warming, because they say then we're going to lose all these species to habitat loss, and that's true. But global warming is not going to go away at all. But we have to save species in order to get through it. So you have species with habitat loss. We need to be working on the habitat loss, but we also need to be cognizant of the fact that they're also being hurt by global warming. It's not just let's look at habitat loss now and that's it, because they really are being insulted by a lot of other things. Now, once a species, this is the other thing, as somebody was saying, well, we'll get this under control and then we'll have as many species as we have right now. No, it doesn't work that way, because once the species goes extinct, it goes extinct. So if we lose things to invasive species, to habitat, to poaching, they're gone. And so what do we do? This is getting back to what do you monitor? It's the same type of thing. It's not an easy question, but I agree with you 100%. Very much so.
This might be a good stopping point.
Okay. Thanks, guys.
Thank Terry.